So NumPy array, we can create an array through this. If you pass data and NumPy dot array, it will create. So normally when you use a NumPy, you can put some alias name NP. Normally in industry we are using NP dot array. So this is a NumPy. Already I showed, right? This is a one direction. Okay. If you want to create a two-dimensional data, you can create like this: a list of list. Normally it looks like list of list. So if you have any confusion what dimension is their data, okay, you can just count this square bracket. Okay, how many square based on that, because it's not actual things, but normally we can remember somewhere, right? Through that we can see that. Okay, so this one is a two dimension. If you want to check how many dimension, okay, here we are creating NumPy array, NumPy n dimensional array. It's showing the result like this. If you want to find the shape, how many rows, how many columns it has, so you can see that one. It has 2 rows and 3 columns. 2 rows and 3 columns. So 2 rows, 3 columns. You can 2 rows, 3 columns. Okay, this one. 1, 2, 3, 4, 5, 6. 2 rows, 3 columns. So in everywhere after getting data, we have to check shape, how many rows are there, how many columns are there. For that we can use this command shape. So a dot shape, a, this one is a, right? How many rows? 3. Here only one row only, right? But here if you see it shows 3. Normally if you define any vector for visualization, we are showing it in this way, but how it looks: 1, 2, 3. It our actual representation is like this only, but actual format is this. That's why we are having a 3 rows. So if you want to check item, okay, inside there are multiple elements, right? If you want to check what data type, okay, you can check D type, this command. Okay, so if you want to check how many dimension, as I said earlier, the number of each column is a dimension. You can check B is equal to n dimensional. Okay, actually this one is a in vertical form, 2-dimensional data. 2-dimensional already we have seen, right? 2 axis. It has a 2 axis. Okay, x and y axis. So n dimensional, a dot n dimensional, a is a single dimension, 1-dimension array. If you want to check, this is a basic function already we have seen. If you want to check a type of a, what it says, NumPy type, NumPy n-dimensional array, default nd array it gives. Okay, similar to range, we have seen range function. If you give any values, it calculate from 0 to that number minus 1. If you are starting point, if you give the starting point, it will start from there. Similarly, you have arrange, okay, some create array values. So 10 means 0 to 9. Okay, this is not a list, this is array. Okay, so next one major advantage of NumPy is performance wise it's faster than other type, okay, data type. Here we can measure that one, some simple calculation. So we have some range function. We have a 10,000 range value for every item, every elements we are getting some cube value of that element. So we are using some comprehension function for I in C. Already we have seen this one, right? For I in C. Okay. So every items we are calculating cube of that item. So how much time already executed? 19.7 millisecond. Okay, 19.7 10 to the power of minus 3 millisecond means. Okay. Okay. Here we are using the same function, arrange the same value. Instead of for loop, simply we can calculate, because this one is a sequential, that's why it took time. But here entire parallel, it is working in a parallelly through parallelism. Through that, because of that, C dot NumPy cube. So enter value here 141 microsecond. Microsecond 141 10 to the power of minus 6. Okay, there is a difference. Okay, 10 to the power of -3 -6. Okay, so here the same function. Okay, one more example for identifying the calculating the performance. L1, it will be varying, but always lesser than that list operation. Okay, here we have a some list 1, list 2. Okay, so there is a list 1 and list 2. We are calculating time. So percentage time 80 means it will render you time, how much time it takes for this operation. Okay, list map, we are using lambda function. We are passing x, y from L1, L2. Okay, so how much time it take? X and y, printing x and y. Okay, parameter is x, one value is x, another one is y. We are multiplying, this is output. Okay, for lambda function already we have seen. So it takes 10.3 millisecond. We have a two arrays. We are multiplying two arrays simply 97.2 microsecond. This millisecond, microsecond. Okay, performance wise always faster than any other data type. Okay, here, yeah, so we are doing some multiplication normally. Okay, so how to create a numpy we have seen through arrange function. Okay, arrange, range, the concept is same. If slicing also the same thing, you have to give three parameters. If you are not giving it, take the default parameter. You have to put start, stop and step. Here we are giving start and stop value. From 2 to 11, it will be getting created array. Here we are giving start, stop, step. So this way you can create some random arrays, ND arrays. Here this one is a zeros. Okay, there are different type of matrix we have already studied. Okay, in schooling, different type. Okay, this is if you want to create the entire item zero, there is a numpy zeros function. You can mention number of rows and column. It gives the zeroth array. Okay, zeroth n dimensional array. If you want to create the entire item is one, okay, you can create you can use this function. And I means only it has a diagonal or element, it has a one, values is one. If you want to create a entire full matrix, a full dimensional array with the 2.2 or any other value, if you give, it will occupy the entire array with this value. So size you can mention 3 cross 3. Okay, so you can, if you want to, because default, if you are not giving any value, default it creates some float values. Here if you see you are creating 3 cross 3 matrix, diagonal is 1, but always 1 dot 1 dot 1 dot 0 dot, because numpy, if you create any values inside the numpy, it creates a default as a float value. That's why dot is coming. So if you put d type is integer, without that you can create this one. The second parameter, if you create anything, you can mention the what document data type you want. Okay, so you can do that. In diagonal, yeah, you can create a diagonal matrix. Diagonal matrix is nothing but, okay, it has values in 1 2 3 4 5. Okay, only diagonal elements has the value here. In np.array 1 2 3, so we can duplicate. Okay, 1 2 3 1 2 3, we have, this is actual array. Okay, so you can tile, okay, duplicate. So here 3 cross 2 means entire 3 items getting duplicated here. Okay, so this is called a tile. Okay, you can we will see some broadcasting. I will share that document, broadcasting. Okay, if you do any operation between the array, if there is a so equal size, okay, it will be duplicated. That is called broadcasting. We'll see later. So NP array, okay, here only one item is there. Here 1 2 3. So how many items in okay, 1 2 3, this one actual item. 3 items row wise, 1, 2, 3. 2 items column wise. This is a one item, right? One item. This one is another item. So 3 items in the rows and 2 items in the column. 1, 2, 1, 2, 3. Okay. So that's what I explained here. Okay. Okay, if you want to create many times in okay, in data analytics, we have to create some random number. Okay, because we want to compare one data type to another data type. There are many places are there. You can create a random number. Okay, so for that in Numpy there is a random function. You can create some random number from 0 to 1. It will create that. Okay. So if you want to create a random number between 2 to 5, there is some logic. Normally we don't, I don't remember this one. Every time I forgot. But if you want to, you can use this line, okay? A random number between 2 to 5 means the syntax is this one, okay? 50 star something. Okay, here we can use this, okay, random number 3 cross 3. You are putting the dimension, which dimension you want. A 3 cross 3 matrix, you have to fill with some random number. If you are not mentioning anything 50 and plus 2 something, it will create a random between 0 to 1. Okay, because always, yeah, the scaling part we will see in the later part, scaling. Because in machine learning, we are using some scaling between 0 to 1 data. Okay, why we need to use that one, we will discuss later. Okay, now just think about a random number. You can generate a random number. This one is a line space. We are having a random number between 1 to 50, 100 equal space. Okay, here think about it. We are having a start number is a 1, n number is 50. We are creating 100 equal space number. Okay, from 1 to this number is space is equal. This number to this number space is equal. Okay, like this 100 line space 100 equal space 1 to 15 we can create, okay, through this function. So item size, okay, here we have created some number. Okay, a array has some line space equal space number, some 100 values. Each values memory, how much memory it use. Okay, 8 bytes. Okay, so item size means normally this we can remember. Item size means how much memory it occupies byte wise. Okay, it says that one. Okay, arrange 24 0 to 23. If you want to reshape, okay, arrange only, it has a one dimension only entire thing comes in single line. If you want to create a 3 cross 3 2 cross 3, you can use some reshape function. It should clearly tell you 2 3 3. Okay, here 2 3 3, it will be confusing if you have a 3 parameter in 3 shape. 2 parameters means you can easily find. 3 cross 3 means 3 cross 2 means 3 rows 2 columns. Already we have seen what is 2 3 3. Okay, so you should remember this one. Okay, here I will explain. It looks like a 3 dimension. Okay, here this one, right, this one comes here. Think about some cube. Okay, this one is 0 1 2 3 4 5 6 7 8. Think about another cube. Okay, here there is a number. This number is so 9 10 11. This is 11 box. So here backside is look similarly. Okay, there is a 9, all the rows columns in this block. Okay, it's getting occupied here. Okay, the backside. How many depth is there? 2. We have one matrix here, another matrix backside. Okay, we have 2 depth. How much height? Rows? We have 3 rows. Okay, how much column? We have 3 column. 2, the first parameter actually it tells about depth, how many depth. And this one is a row size, this one is a column size. You can visualize this dimension, okay? How it looks, 3 dimension. We are having a 3 dimensional data. So it has a row x, y, z, 3 axis. It will be reshaped, okay, like this. 0, 1, 2, 3, but it reshaped only 17 because the size will not be matched, okay? Even though if you give any other number, suppose instead of 20, we are having only 2, 3, 3, okay? Based on that, it will be first elements. It will consider the first element and reshape it. Okay, here adjust dimension based on that, okay? So here based on the element size, it will adjust. If you give -1, so -1 will automatically adjust the dimension. So practice it, okay, play with it. Okay, we are not using normally, we are checking only reshape. We can change the reshape, okay, whatever dimension, you will see it later.